You know how you just tap an app on your phone and it just opens? Or you click on a file and boom, there it is. It's totally seamless, right? Almost magical. But have you ever stopped to think about what's actually happening behind that screen? I mean, let's be real. You think you're the boss of your phone, right? You tap, you swipe, you give the orders. But what if I told you there's a secret manager, a powerful boss working 24/7 in the background, making sure everything you ask for happens flawlessly? Yep. With every single click, every tap, every single key you press, there's this invisible force, this ghost in the machine, conducting this incredibly complex dance between the shiny screen and the circuits inside. It's a thing that makes all of it work. And guess what? That ghost, it has a name. It's the operating system, the OS. It is the absolute unsung hero of your digital world, the master conductor of the whole show. And today, we're going to pull back that curtain and see exactly how it does its job. Okay, so what is an operating system, really? Well, the best way I found to think about it is like this. It's a digital conductor. It stands right there on the podium between you and this wild, complicated orchestra of computer hardware. Now, if you want the textbook definition, sure, it's system software that manages hardware and software resources. But here's what that really means. The OS is the essential bridge. Without it, your $1,000 smartphone, it's just a fancy paperweight, a box of useless circuits. The OS is what turns that box into the incredible tool you use every single day.
So the OS is basically juggling two massive jobs at once. First, it's the ultimate resource manager. Think of it like a super fair, but also super strict boss. It's the one deciding, okay, Spotify, you get this much processing power. Chrome, you get this chunk of memory. It keeps everything running without a fight. And then, at the same time, it's also this amazing translator, the extended machine. It takes all the crazy, complicated language of the hardware, all the ones and zeros, and translates it into the simple stuff we understand, like icons, folders, and windows.
And like any good boss or conductor, the OS has a very clear job description. It's got a whole list of critical tasks it's constantly juggling to make sure the whole performance goes off without a hitch. So let's break it down. There are basically 5 core jobs your OS is always doing. You've got process management, that's just making your apps run. Then there's memory management, that's the magic that lets you switch between like 20 different apps without your phone exploding. Storage management keeps all your files and photos organized. Device management makes sure your keyboard, your mouse, your printer, they all actually work. And finally, the user interface, that's the pretty part, right? The icons and windows that you actually see and touch. But here's a key thing to remember. Not all operating systems are created equal. Because think about it. The orchestra inside your phone is totally different from the one in your car or the one in a massive supercomputer. They need different kinds of conductors. And you can see just how diverse it gets. You have big time-sharing systems like Unix, which were designed for tons of people to use the same computer at once. Then you get to something called a real-time OS, or RTOS. This is for stuff where timing is everything, like the braking system in a car. A delay there is, well, it's not an option. You've also got these tiny, specialized embedded OSs in things like your microwave or Wi-Fi router. And of course, the ones we know best, mobile OSs, like Android and iOS, built from the ground up for touchscreens and being on the go. So that leads to a big question. How on earth do you even build something this complicated? All right, let's pop the hood for a second and look at the 2 main ways it's done. Okay, so on one side, you have what's called a monolithic kernel, the all-in-one approach. Imagine the entire OS is just one massive single piece of code. The good news, it's super fast because all the parts can chat directly. The bad news, if one tiny thing goes wrong, the whole system can come crashing down. On the other side, you have the microkernel. This is more secure and modular. Here, only the absolute bare essentials are in the center. Everything else is a separate program. This is way more stable and secure. But having all those separate parts talk to each other can slow things down just a tiny bit. Of course, in a real world, it's not usually one or the other. Most modern systems we use, like Linux for example, are actually a hybrid. They take the fast core from the monolithic idea, but then add the flexibility of loading modules like the microkernel does. It's really an attempt to get the best of both worlds. So let's zoom back out. When you really think about it, from managing your memory, to talking to your printer, to even just showing that little blinking cursor on the screen, every single thing is being perfectly orchestrated by that digital conductor. It really is the invisible hero. The OS is the software that breathes life into the cold heart circuits and glass of our devices. It transforms that complex collection of electronics into the incredibly powerful, useful tools we rely on every single day.
So here's a little challenge. The next time you tap your screen, the next time you just effortlessly open an app, maybe take a half second to think about that invisible conductor in the background, working like crazy to make it all seem like magic. Pretty cool, right?